With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with a question which says a battery of EMF V volts, resistance R1 and R2, a condenser C and switches S1 and S2 are connected in the circuit as shown. The capacitor C gets fully charged to volts V when. So we have been given with the situation, so we have to check when the capacitor will get fully charged to the voltage V. So let's take one by one every case. So we can say in this case, first let's discuss about the second case, that is S1 and S2 both are open. So we can straight away say that when both the switches are open, so no current will flow. So for B part we can say S1 and S2 are open, so no current will flow. Therefore capacitor cannot be charged in this case. So we can say capacitor will remain uncharged, or we can say capacitor will be isolated in this case. So this cannot be the answer. Now we can check about when S1 is open and S2 is closed. So then also we can say the battery source will be isolated, or we can say the battery source will not be directly connected to the capacitor and it will not be charged. So we can say when S1 is open, S2 is closed, then also the capacitor will not be charging. So we can say this option is also the incorrect option. Now among A and C we have to check the option. So now let's check about option A. So we have been given with the situation when S1 and S2 both are closed. So we will understand this. So let's suppose S1 is closed and S2 is also closed. So we can say we are discussing about the A option. So we can say the current will start flowing in the both the sections. So let's suppose in this section the current flowing is I1, and in this section let's suppose the current flowing is I2. Alright. So we can clearly see that when I1 and I2 both are flowing, so after some time the capacitor will get fully charged, and if they fully in the fully charged condition, or we can say in steady state condition, in steady state the current flowing through capacitor will be 0. Alright, so in this section let's suppose the current flowing is I, so I will become 0 in this case as the capacitor has been fully charged. So let's suppose the potential at this point to be as V dash. Alright, so if we can be able to calculate the potential difference across C, so we can be able to comment whether the capacitor will be fully charged to V volt or not. Alright, so before that let's understand what will be the capacitor C when it gets fully charged. So when it gets fully charged, the condition will be Q will be equals to CV. So this is the fully charged condition, or we can say maximum charge condition. Alright, so this will be the maximum charge. So we will try to find what is the potential difference across this. If it comes out to be V, so we can straight away say that yes, it will be fully charged in this case, and this option will be the correct. So now we have to check about the potential difference. So for that we will first try to calculate the value of current in the steady state condition. So we can say current in the circuit will be, here in this section current will be 0. Alright, so from here we can say if this is V, so this potential will also be V, and let's say that this potential will be 0. If we are assuming this negative terminal to be at 0 potential and this to be at V potential. Alright, so from here we can say that in this condition if we apply the terminal potential concept over here, so we can say, let's suppose current I1 is flowing in this fashion, so we can say over here V minus of I1 R1 will be equals to V dash. Therefore from here we can clearly see that the value of V dash can be written as V minus of I1 R1. So from here we have to first calculate the value of I1. So we can straight away say that in this steady state condition we can say the current flowing by Ohm's law we can write it as to be V equals to I into R. as this section will be no more into function, so we can say the resistance R1 and R2 both will be in series, so we can just add them up. So we can say it will become R1 plus R2. Alright, therefore from here we can say the value of current will be equals to V by R1 plus R2. Alright, and if you substitute this value of current in this section, that is I1, so we can say therefore V dash will be equals to V minus of V upon R1 plus R2 into R1. Alright, so this can be clearly seen that there is a potential drop. Actual potential, if it was V only, so we would have said that the capacitor will be charged to V volt fully. But here we can clearly see there is some term that has been getting subtracted from the potential V, so we can say it will not be fully charged to volt V. So we can straight away conclude that this also will not be the correct answer. Alright, so now we are left with the only option, that is S1 and S1 closed and S2 is open. So we can discuss this over here. So we can say about this option, that is C option, S1 is closed and S2 is open. So we can see clearly that if S1 is closed and S2 is open, so we can say this the second half of the circuit will be no more into consideration. So we are left with what we can draw it over here, the situation. So what we are left with is we can draw it over here. So this is our battery source and this is our resistance R1 and this is our capacitor. So when we are saying when S1 is closed, alright, so this is what the situation will be, and we can clearly see that this situation is a charging condition of a capacitor, which we have already studied. This is what the charging state of capacitor is, and in this case we can clearly see the potential. If we try to analyze the situation over here again, so we can say the current will be again we can say that, let's suppose the current flowing is I in this case, so we can again say we will first try to calculate the potential over here. So let's suppose it has to be V double dash, so we can say this potential is V, this is 0. So again we will try to calculate V double dash. If it comes out to be equals to V, so we can say the capacitor will be charged to V. So we can say V minus of I R1 will be equals to V double dash. Alright, and also we can say when the capacitor is fully charged, so in this condition we can say current flowing in this section will be 0. So we can say when the capacitor has been fully charged, so the value of current will be 0. So we can say therefore V will be equals to V dash, and this implies that the potential will be the same across the capacitor. So we can say the capacitor will be charged to a potential of V. This can also be understood by the equation which we have derived in the theory part, that is charging, that is Q equals to CV 1 minus e raised to minus t by RC. Alright, so from this equation we can say that this is the value of maximum charge, that is CV, when a capacitor has been connected to a voltage source of V volt. Alright, so this is the alternate, we can say alternately we can remember this, or by this method also we can get the same result. Alright, so here we can give a reason, I will be 0 in so this is what the answer to the question is. So if we say answer C is the right answer to this question. So I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.